Okay, so today we are doing 2.5, which is similar figures. Okay, so our objective is I can define similarity and identify similar figures. Okay, so figures that have the same shape same shape, but not necessarily the same size are called similar figures. So definitely same shape, but not necessarily the same size. So like a big circle and a little circle. And we'll talk about how we know it's the same shape or not. Not just necessarily a triangle, but the dimensions have to be related in a way. Okay, and you kind of explored that on your activity yesterday, but we're going to talk about it. Okay, so if you look here, triangle ABC is similar to triangle DEF. Okay, so we have to have corresponding side lengths that are proportional. Okay, oops, are proportional. So corresponding side lengths are proportional, and then corresponding angles are congruent. If I can spell. Okay, so the angles have to be the same. Okay, so that's how we know if it's similar. Okay, so corresponding angles are congruent and the corresponding side lengths are proportional, which means that when I divide my side lengths, so A, B, and DE, so if you look here, A and D go together. Okay, so I know angle A is congruent to angle D. Okay, and because of this has 3 hash marks. Angle B is congruent to angle E, and angle C is congruent to angle F because it has 2 hash marks. Okay, so if I look, here's my 3 hash marks and my 1 hash mark, so those are my corresponding sides. So when I divide AB by DE, I should get the same thing as when I divide BC by EF, and when I divide AC by DF. And if you flipped these over and did DE divided by AB, you would get the same thing as EF divided by BC and DF divided by AC. Okay, you would get the same thing if you flipped them over. Okay, so if I drew arrows and drew the same thing, it would be the same. Okay, so now over here, okay, when I'm putting this in symbols for my figures, I'm saying that triangle ABC is similar to triangle DEF. Okay, so example number 1 says which rectangular is similar to angle A. Okay, so I need to figure out if I divide this by this and this by this, do I get the same thing? So if I'm just going to go A, B, C, D, E, F, G, H, I, J, K. Oh, okay, that'll just help me with labeling. Okay, so I'm going to do BC divided by FG. Okay, and that should be congruent or equal to CD divided by GH. So CD and GH go together, and those sides go together. Okay, so if I do BC divided by FG, that's 3 over 2. And if it's congruent, it should be divisible, or should be equal to this one divided by this one, which would be 6 over 6. Well, 6 divided by 6, we know that's 1. And I know for a fact that 3 divided by 2 is not 1, so it's not rectangle B. Okay, but we want to check just to make sure this is right. So this time, it should be BC divided by JK should be equal to CD divided by KL. Okay, so when I do that, okay, BC is 3, JK is 2. It should be equal to CD, which is 6, over KL, which is 4. Okay, well, I can't simplify this. Well, and even then, I could even type it on my calculator. If I do 3 divided by 2, I get 1.5. And if I do 6 divided by 4, I get 1.5. So those are the same. And I know this is a rectangle, so they're all 90-degree angles. Okay. So rectangle C is the correct answer. Okay. So I want you to find dimensions of a rectangle that would be similar to rectangle B. So you're focusing on rectangle B. Okay. Oops, that was a very, very poorly drawn rectangle. Okay. And you're finding a dimensions of a rectangular that's similar to the rectangle, because that's the one we didn't choose in example 1. Okay? Okay. Example number 2. It says the triangles are similar, find x. Okay, so I'm going to set up a proportion. Okay? So I'm going to do this side over this side, so 6 over 9. Okay, equals, so I have this side and this side go together, and then this side and this side. And because I put the 6 in the numerator in this fraction, I have to put the 8 in the numerator in this fraction. Okay, they have to be in the same spot. So these came from the same triangle, and these came from the same triangle. Okay, so I'm going to cross multiply. So I'm going to go like this. So 6 times x is 6x. 9 times 8 is 72. Okay, and then if I divide by 6, I get x equals 12. Okay, so x equals 12. There's your answer. Okay. Okay. Do you try number 2, A and B both? Okay, an artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid and the replica is 3.75 inches. What is the height, h, of the trapezoid in the replica? Okay, so I know that this and this go together. This one makes it a little bit easier because this side, definitely know this side and this side go together, which means that this side and this side go together. And then this side and this side go together. Okay, so I'm going to do 15 over 3.75. So I'm going from this one to this one. So 15 over 3.75 is equal to 12. And remember, 12 and 15 come from the same trapezoid. Okay, so they go on the top, and then h goes on the bottom. Okay, so I'm going to cross multiply. Okay, so I know that's 15h. And then if I do 12 times 3.75, that gives me 45. Okay, so then I divide by 15. So remember how I said equations will come back to haunt you if you don't know how to do them. And when I do 45 divided by 15, I get 3. So the height is 3 inches. Okay. So they are asking that if this is 4.5, what is the length of this? So you could use, there's multiple things you could do. So try to solve that one out. Okay. And this one didn't get put on here, but this is 1 point in your quick check. Okay. Okay.